Interval notation. So we will often want to talk about continuous segments of the real number line. We've already done work with this in the last lesson using what is known as inequality or set builder notation. Okay, that's what we used anytime we solved either a compound inequality or just a regular inequality. Today we're going to see a very simple way of showing those solution sets. Okay, a little simpler than using the inequality symbols. It says, for each of the following, graph the portion of the number line described by the inequality and then write the equivalent using interval notation. So interval notation is just sort of a simpler way to represent our solution set. So this first one in letter A, it says -3 is less than or equal to x, which is less than or equal to 5. Well, from the last lesson, we learned that when our x lies in between, okay, two endpoints, that is considered an AND compound inequality. So from -3 on our number line all the way up to and including 5. Now, how did I know to fill in both those circles? Because that equal to means to include, okay, those two endpoints, -3 and 5. And where does the x lie? The x lies in between, and in this case, including -3 and 5. Okay. So now it says equivalent interval notation. So I want to write this using different notation. So we start, and I always say, when we've got the number line, we read from left to right. So where is our starting point? Our starting point is at -3. And where is our ending point? It's at 5. Now, how do we indicate that we include -3 and we include 5? Interval notation, for when we include, we use brackets. So that's the same exact thing as the inequality notation that we were given. This is just interval notation. They're equivalent, same thing, mean the same thing, just different notation. So let's look at B. So -6 is less than x, which is less than 4. Again, that's an AND compound inequality because the x is in between. Okay, it's got to be true for both pieces of the inequality in order for it to be true. So where is our starting point? Our starting point is at -6, but it's not included because it's a less than. And our ending point is at 4, but again, it's not included. And it's everything in between. We could pick any number in between, so say we picked 0. Is -6 less than 0, which is then less than 4? Is that true? It absolutely is. Okay. So how do we write it in interval notation? Pick your starting point, -6. Pick your ending point, 4. Now, how do we indicate to not include? Because we didn't include -6 and we didn't include 4. The notation for to not include is a parenthesis. So not include 6 all the way up to and not including 4. So let's look at C. So -4, which is less than x, which is less than or equal to 8. Now think about how I say this each time, just so you're comfortable with reading that inequality in notation. So you'd say -4 is less than x, which is less than or equal to 8. My starting point on -4, but it doesn't include -4 because there's not an equal sign there, all the way up to and including 8. 1, 5, 6. There we go, 7, 8, right there, and it does include, sorry, my phone's ringing, and we're going to include everything in between. Everything in between. So what does the interval notation look like for this? So to not include, so let's write down our starting points, -4, let's write down our ending point, 8. We're not including. So what's the symbol to not include for interval notation? It's a parenthesis. What's the symbol to include? Bracket. Always keep in mind interval notation. This is inequality or set builder notation. They're the same thing. Letter D. How do we indicate letter D? X is greater than or equal to 4. So this isn't a compound inequality. Okay, this is just a single inequality. So we would put 4 on our number line, and it includes 4. So we'd fill it in, and where are all the values of x greater than 4? They're all to the right, and it continues on. So my starting point is 4. But what's my ending point if I have this arrow here? Okay, there is no ending point. It goes to infinity. So we include 4. So include is a bracket. Now infinity, because infinity is not a number, okay, it's not a specific number because we can't go to infinity, kind of like infinity and beyond. So infinity always gets a parenthesis, okay? So let's look at E. E says x is less than 5. So we're not including 5 because there is no equal sign. And where are all the values of x less than 5? Less than goes to the left. All of those numbers to the left. So now, because we read from left to right, where is this sort of starting point? Okay, it's this arrow here. So this isn't positive infinity. This is negative infinity. And it goes up to 5. Now, any type of infinity, because I said infinity is not a number, it always gets a parenthesis. It can't possibly be equal to negative infinity. And 5, not included as well. And letter F. So this one is flipped around here. And I always say when that is the case, read backwards. Read from the X. So if we read from the X, we would say x is greater than negative 4. If you really wanted to rewrite it, that's fine too. Just be super careful on how you rewrite it. So x is greater than negative 4. Okay. So my starting point is negative 4, and it's not included. And where are all the values of x greater than negative 4? Greater than goes to the right. So interval notation. My starting point is negative 4. My ending is that arrow, so that means it goes to infinity. Negative 4 is not included, so it's a parenthesis, and infinity always gets a parenthesis. Okay? So it says one of the great advantages of interval notation, what we just learned here, is that we essentially need to know a starting value, an ending value, and whether they're included or not. Okay? Start value, end value, include or not. Remember, include needs a bracket. To not include is a parenthesis. Right? Then exercise number 2 says which of the following represents the equivalent interval to negative 12 is less than or equal to x, which is less than 4. So think to yourself, include, we need a bracket. Not include, we need a parenthesis. So we need bracket, parenthesis. So immediately I would eliminate those two. And now bracket, parenthesis, bracket, bracket. There's our choice, number 3. Okay, go ahead and flip the page. It says, eventually we will use interval notation to express solution sets to inequalities as well as to describe sets of interest to us. So we are going to use interval notation a lot this year, and you will use it a ton later on in your math career. So exercise 3 says, solve the inequality given below for x. Then they want us to graph the solution on the number line and then state the solution in interval notation. So 3 pieces. So, I don't think I'm going to subtract 12. I just looked at this and I'm like, oh, let's do something different here. And why am I choosing to do something different? I'm going to choose to add 4x to both sides. And why did I choose that? It wouldn't have been wrong if I subtracted 12, but I decided I didn't want to divide by a negative. So that's why I added 4 to both sides. So when I divide by 4, I read from my variable x is less than 3. So I put my 3, and it's not included. X is less than goes to the left. My interval notation. So we read from left to right. Where's my starting point here? So that's coming from negative infinity, and it's going all the way up to and not including 3. Okay? To check yourself, pick a point. Okay? To check to see that you solved it correctly, say pick 0 if you can, and plug it into the original, and then go to your calculator. So this is something a little extra, but if you can check something, especially on a quiz or a test, have at it. Do it. Guarantee that you're going to get the correct answer. So is 12 greater than 0? It sure is. That's true. Okay. Let's scroll down and take a look. So it says, two inequalities have solution sets given in interval notation below. Okay, so we've got inequality 1. It includes negative 3 and doesn't include 2. And inequality 2 doesn't include 0 and goes all the way up to and doesn't include 4. So it says, write an interval, okay, so an interval that represents all values that are solutions to both inequalities, meaning an and situation. Draw number lines to help you think about that solution set. So my first one, inequality number 1, I'm going to put a 0 there, and then I'm going to my starting point and my ending point, and we include and we don't include, and it's everything in between. Inequality number 2, my 0, that's my starting point, my ending point is 4, don't include, and it's everything, okay, in between. I should back that up a little bit. I'm going to erase that just for the sake of, because my scale is off. This is a 2 here, and then right below it's a 4, so clearly that's off a bit. So I'll just change colors and keep it on the same number line. So 0, okay, all the way up to 4, right? And now, where do those two inequalities overlap each other? The and. So right in there. So what is that green piece that I just kind of bracketed in? And that goes from 0 all the way up to 2. Okay, we didn't include 0 there. Okay, all the way up to 2. Okay. So now, part B, let's do the same thing. See what it says. Write an interval that represents all values that are solutions to either of the inequalities. So an or situation. Now remember, this was an and, okay? So it had to be true in both in order for it to be considered the solution. Again, draw your number line to help. So if I start out and draw my number line, and I put inequality number 1 on here in purple, and 0, negative 3, and 2, include, don't include, and everything in between. And then inequality number 2, I'll put in blue, 0, don't include, up to 4, and don't include, and everything, okay, in between there. Now, because it is or, it could be true for one or the other to make the whole thing true. So what am I going to bracket in as my solution for this? Remember, one or the other could be true. So if it's or, it goes from start to finish. Okay? Or goes from start to finish. So in that case, my starting point is -3, and my ending point is 4. Okay, so OR is the union of those two sets. Okay, and is the intersection of those two sets. Okay, where they intersect, where they cross each other. All right, and I'm going to give you the answer to number 5, and that is 1. By all means, look at it, and we're going to practice interval notation some more in class. Nice job, guys.